I've had some requests for nomenclature of carboxylic acid derivatives to do a video on that chapter 18 topic. You have to first remember that in chapter 17 we learned how to name carboxylic acids. The longest chain is 5 carbons here. That's a pentanoic acid. Carbon 1 of carboxylic acid derivatives and carboxylic acids is the carbonyl carbon, so the proper name is 3-methylpentanoic acid. In chapter 18, the first derivative, the most reactive of the derivatives, is the carboxylic acid halide. Clearly, the carboxylic OH is now a halogen, here a chlorine. Focus on what stays the same in naming these derivatives and what changes. We keep the whole name up to the O, and we lose the ic acid. The carboxylic acid halide is now an ill chloride. So once again, you lost the ic acid only and replaced it with ill chloride. It's as if the group to the left is now a group. Those are called acyl groups. Acyl groups. Which are carbon groups including a carbonyl. And it's as if that is attached to a chlorine and named as an ionic compound. A carboxylic acid anhydride keeps everything up to the ic this time, mostly because we kept the oxygen. And notice there are 2 carboxylic acids glued together with water missing in the middle, thus explaining the name anhydride. And the name of a symmetric anhydride is, in this case, 3-ethylpentanoic, and you change the acid to anhydride. So you kept everything up to the oic, always going back to the carboxylic acid, replaced the word acid at the end with anhydride. Carboxylic acid esters are actually named like ionic compounds. So if you had to name the left portion as an oxygen-containing anion, it would be 3-ethylpentanoate. That's an anion. When naming ionic compounds, the cation goes first. All the carbons in green, they are not a cation in fact, but they are named as if they are. And we name cations the same as groups. It's an isopentyl group. I'd like to expand a little bit on my introduction of acyl groups. To be more clear, there are groups with a carbonyl at the point of attachment. So in our example above, everything up to the chlorine was the acyl group, called a 3-ethylpentanoyl group, here attached to a chloride. Down here, this is a propanoyl group attached to benzene. So one acceptable name is propanoyl benzene. Back in chapter 16, we learned there was another common naming system where you could just name the groups alphabetically and call it a ketone. Ethyl, phenyl, ketone. Here's another carboxylic acid anhydride. Keep in mind that this was actually a dicarboxylic acid before it connected. And we are responsible for naming several of the dicarboxylic acids. Keep in mind that they start with 2 carbons. The first one being oxalic acid, following the mnemonic device, oh my such good apple pie, where we go from 2 all the way to 7 carbons, going with oxalic, malonic, succinic, glutaric, adipic, and pimelic acids. This is of the glutaric variety, this anhydride, because it has 1, 2, 3, 4, 5 carbons. And because it's not an acid anymore, it's actually an anhydride. You keep the glutaric. You do not keep the 3. The 3 was a vestige of the previous example, my mistake. and the name is glutaric anhydride. Amides are not named like ionic compounds. You keep everything up to the oic acid, you lose the O and the ic acid and replace it with amide. If you wanted to follow the rules strictly, we have been keeping the O's, as you know. Notice here and here and here. The only reason they drop the O is because it sounds awkward to say pentanoamide. If I am grading your exam and I see pentanoamide, I will not be deducting any points. So pentanoic acid became pentanamide. The same group on carbon 3, 3-ethyl. But there is also a group on nitrogen. We actually name this where we name normal groups in the beginning of the name and we list them alphabetically. It is an isopentyl group, that's why it's going to be after ethyl. The only question is, how do we indicate that the isopentyl group is attached to nitrogen? The answer is you put a italicized N in front of isopentyl. If there were more groups on nitrogen, they would just be listed alphabetically with their own N, italicized N in front. Recall, this is a secondary amide because the nitrogen has 2 bonds to carbon. And I did not mean to erase the nitrogen. Life would be much simpler if carboxylic acid esters, when they were in rings, were named esters, and cyclic amides were also called amides, but that is not the case. A cyclic carboxylic acid ester is called a lactone, and a cyclic carboxylic acid amide is called a lactam. When naming a cyclic lactone such as this one, you have to break it down first to its parent acid. Remember, an alcohol reacts with a carboxylic acid in a condensation reaction that makes an ester, in this case a cyclic ester. The name should have lactone in it. Here the name is from the parent is 5-hydroxyheptanoic acid. The 5 indicates in the lactone name which carbon closes the ring, and you change ic acid to lactone. Using our Greek lettering system, where alpha is 1 away from a carbonyl, beta is 2 away from a carbonyl, gamma is 3 away from a carbonyl, and delta is 4 away. Another acceptable naming system is indicate the ring closes using the delta carbon, and the name also ends with lactone. When we're naming a lactam, cyclic amide, we have to look at the parent again. The parent is an N-propyl 3-amino. Carbon 3 is this carbon here. 1, 2, 3. There's a 3-amino group on carbon 3 that also has a propyl on it. There's a use of our N again. And it's a hexanoic acid this time. We keep the hexano and we lose the ic acid and make it lactam for both examples. In this case, the ring closed on carbon 3. So a lactam says, a 3-hexanolactam says the nitrogen's on 3 and ring closes using carbon 3. Alternate beta for 2 away from a carbonyl. And there's your alternate name. I'd like to close by discussing a few other acid derivatives that are not carboxylic acids. Here is diphosphoric acid. Here's phosphoric acid. You'll notice diphosphoric acid is an acid anhydride of phosphoric acid. Another name for diphosphoric acid is pyrophosphoric acid. You'll be seeing these extensively as you further your studies in biochemistry. Phosphoric acid, also known as orthophosphoric acid. Biologists often call it inorganic phosphate when it has the H's missing. In truth, under physiological conditions at pH of 7.4, you would lose 2 of these H's because 7.4 is above the first 2 pKa's but not the third. And this would be the form of phosphoric acid in your body at pH 7.4. Also known as physiological pH. I've drawn adenosine diphosphate down here. It's important as a biological molecule. At pH 7.4, all the phosphoric acid sites have been deprotonated. The combination of 2 phosphoric acids glued together is a phosphoric anhydride. This is a carbon R group connected to what used to be a phosphoric acid. That makes that a phosphate ester. Ribose is in the middle. It has 2 secondary alcohols and what we call in chapter 16 an N-acetal or an aminal. And this is one of the nitrogenous base pairs bases called adenine. The combination of adenine and ribose is adenosine. With a phosphate ester on there, adenosine is attached to pyrophosphate. This is not a biological molecule. This is a very nasty molecule, but it does follow the nomenclature of an acid halide. If you look up here, 3-ethylpentanoic acid became 3-methylpentanoyl chloride. Phosphoric acid became phosphoryl chloride. Lose the ic acid, replace with il halide. If there are many OHs, it's understood if there is no ic acid in the name, all of the OHs are gone. One thing I forgot to cover is that nitriles are also a derivative of a carboxylic acid. In class, we discussed the fact that everything on this page that has carbon carboxylic acid derivatives has 3 bonds to more electronegative atoms. So nitriles fit that. That's why they're in the category of carboxylic acid derivatives. Its parent was 3-ethylpentanoic acid, listed above. You lose the ic acid and replace it with nitrile. So 3-ethylpentanonitrile closes our discussion on carboxylic acid derivative nomenclature.